One. Hello, everybody, and welcome to episode 6 of the BeagleCast. Today we have Plout from Imagination Technologies to talk about GPU acceleration. So, hi, Plout. Welcome.
Hello. Happy to be here with you guys.
Do you want to introduce yourself? Tell us a little bit about what you do at Imagination.
Sure. I'm Galatsopoulos. I'm Senior Director of Product Management at Imagination. I'm looking after GPU DDK, open source, and proprietary drivers, as well as our mobile GPU hardware product line.
Awesome. So how long have you been at Imagination in this role?
It's been 3 years and a bit. Started during COVID in 2020.
Awesome. So I have so many questions. I'm not really sure where to crack the egg, right? So we use an Imagination core inside the Beagle Play, right? In fact, almost all the Beagles have used an Imagination GPU, but those of us in the Beagle community are super excited about what's going to happen with Beagle Play here with the GPU driver. And can you tell us a little bit about kind of the vision for open source and Imagination and what you're hoping to accomplish ultimately?
Sure. So open source has been a focus of Imagination in the past few years in multiple different aspects, right? So from developing an open source GPU driver, as I mentioned, to participating in RISC-V community and building our own RISC-V CPUs, or even just using existing open source frameworks for AI and ML use cases, for example, like TVM. So we have been embracing open source from multiple different angles, and we can definitely see the value and the need to continue doing that in the future.
Awesome. Robert, I see you chomping at the bit. Yeah.
I guess we could talk about kind of the status of things like today, because we know, for example, mainline Mesa, we have there's GPU support that iMation's been pushing. For the Beagle Play specifically with TI, we just merged in the video bindings. So theoretically, in the next month or two on the Beagle Play, we should be able to do a full Power VR open source stack with everything that Imagination's done. And so it's, for us, it seems like we're just, going to flip a switch and it just works. But, Plout, for what you've had to deal with, all the internals, Animation always had, they support OpenGL, OpenCL, all the stacks. And you've gone from, well, this has been closed to, well, now I got to work with the community. I mean, just talking about that story is always kind of interesting. It's like what your team has learned and
absolutely
all the pitfalls.
We are starting the journey with Vulkan first, actually. So that's the first graphics API, graphics and compute API that we are going to support in the open source space. And as you're saying, I think we are getting really close to completing the upstreaming of the kernel mode version of the driver. The user mode part of the driver has already been upstreamed into MISAP some time ago, more than a year ago, actually. So once we complete the kernel mode side of things, then we will have the first complete native Vulkan driver in the open source space that can run on our Rogue GPU architecture. And this is going to support one device to begin with. We have been focusing primarily on our AXC 116 GPU, but we can easily extend that to all the additional Rogue architecture GPUs, which is what we plan to do in the following months after that. And on top of that, we are also going to enable Zinc layer on top of the Vulkan driver so that we can support OpenGLES as well.
Yeah, that's kind of the nice thing about the way the Vulkan stack is migrated over the last few years. I think when we were first talking with TI and Imagination about this open source project, initially it's like, okay, we have to do Vulkan first, then we have to look at OpenCL, OpenGL, but all the Vulkan translation layers have like FineWine, they're clarified so much that as long as you have a really solid Vulkan driver, it's like the community kind of takes care of the other stacks. So, and that's where Zinc will be important for. We could actually have desktop-like environment on the Beagle Play and other TI devices and the iMage GPUs where you just load up. It's running Vulkan, but you're doing OpenGL, OpenCL, OpenGL ES.
Absolutely. It's as you're saying. I think that lots of the graphics API are now consolidating, under this kind of translation layers, and the baseline driver is Vulkan. Then you're having all the other APIs supported through these layers, and this has lots of benefits in terms of the effort and the focus that GPU vendors and other experts can put to optimize the Vulkan driver. Then all the other APIs get the same benefits for free if you want.
Yeah, you get more testing, and if someone wants to run a DirectX 9 Vulkan wrapper, it's like, oh, suddenly DirectX 9 works on this too. So it's
Yeah,
it kind of helps spread out. And
yeah, we've seen that even DirectX, as you mentioned, we have seen occasions in the market where people have tried to emulate that as well. So possibilities are limitless, I guess.
Well, this I think may be my chance to ask really stupid questions, or at least try to express my incomplete knowledge, right? I know very little about the Vulkan API, but my understanding is it lets you write some type of kernels, meaning some type of small segment of code that you could loop across a large number of array of processors of some kind. I don't know if that's accurate in the slightest or not.
Vulkan driver provides certain benefits. It's a lower level API. It can run in a multi-threaded environment, as you have hinted. So yeah, there are lots of good performance optimizations that can be utilized, and they were not possible with other APIs in the past.
But again, I know nothing about Vulkan, right? I just have to try to guess as to what it might be in order to try to produce 3D graphics acceleration. But I would think you would call some functions to generate some type of pipeline, and so there has to be some type of compilation or something that ultimately happens to run the native imagination environment. If you can give any sort of high-level picture for somebody that doesn't do GPU programming.
You mean explain how does the Vulkan driver works? I think it's quite complicated topic to dive into right now.
Just a high-level perspective, right? Just as a novice, for somebody that's all of a sudden got this extra compute capability exposed to them. How do they?
What I mentioned before about this being a lower level API is the primary benefit of it, right? So Vulkan is actually a more difficult API to code if you're not an expert developer on graphics, and that's a pro and con at the same time, if you want, because being more complicated, it means that it gives you a lot more access to the underlying hardware, and you need to understand the way that the GPU works a lot better in order to optimize your content for that. On the other hand, you have full control. So, with more controls comes more responsibility. And in the hands of expert developers, that can make a huge difference on the performance of the final app. And for those developers who are not experts and they're not comfortable, coding directly into Vulkan, as we said, there are all the additional translation layers on top that give you access to higher level APIs, libraries, and other things that giving easier programmability, and they are simpler to use.
Just
But then,
something
of
like
course,
Mesa,
maybe-
right? You look at a project
guess-
like Mesa that would provide a GL programming layer, right? So maybe
Yeah.
OpenGL might be a more familiar programming layer that people could use to access the Vulkan drivers. Would that be accurate?
Yeah.
The drivers
lot of
actually
code-
acting as a translation layer and letting you use OpenGL or whatever you're familiar with, but underneath it, it's still doing Vulkan calls, is what you're saying, right?
Yeah, that's all the wrappers does.
Correct. Yeah, exactly. It's a thin layer that translates the API and passes down the right stream of commands to the native Vulkan driver.
Does it provide OpenCL type of functionality as well, right? Are people writing OpenCL layers, right? So that OpenCL kind of relates a little bit more to what I was trying to say earlier, right? You can write little kernels, right, and parallelize those little bits of code with OpenCL, and provides for the memory allocation between the main processor and the co-processors. But I don't know if like Vulkan looks at all like OpenCL or not.
Well,
Or if there's a translation layer.
Vulkan has compute capabilities as well, right? So you can develop compute applications just using Vulkan natively. But there are similar, translation layers on top that could allow you to run OpenCL applications on top of a native Vulkan driver. Same as we said for Angle that can accelerate OpenCL ES or even OpenCL desktop APIs on top of Vulkan.
Now, while the OpenGL kind of kept on going forward, Vulkan was kind of a fork. I mean, it's a fork of AMD's original, was it Metal? I'm trying to think what it was called, but it basically became
I think Metal
OpenGL.
is Apple.
Yeah, Metal's Apple. It basically came like OpenGL next. They merged in a lot of the OpenCL, a lot of OpenGL things, and they made Vulkan, which is a lot lower level language, and it could do a lot of things that was really complicated in OpenGL and OpenCL, but it doesn't, do all of them. But so it's pretty easy to translate from Vulkan back to OpenGL. But usually you'd write your own Vulkan application versus an OpenGL application.
Yeah, if you write your own native Vulkan application, I don't think there is any benefit trying to translate that to an OpenCL ES or OpenCL or OpenGL because they are higher level APIs if you want. So what you want to do is actually feed it to the GPU through a well-optimized driver so that it can execute the best possible way.
And that's exactly what Zinc does. Zinc just takes your Vulkan driver and allows you to run OpenGL on top of it. So the goal was to run desktop stuff. So
yep. And now we are having conformance passing on OpenGL 4.6 through the Zinc layer. So that's a quite major achievement, and we're really happy to see that. And we are seeing that the performance is really good and comparable to native OpenGL drivers. So
I think on the last RFC that was posted, you're at 88 point something compliance, I believe, or
You mean on OpenGL 4.6?
Yep.
No, it's fully conformant.
Okay, fully conformant. That's awesome.
Yeah. It has been for a few months now.
Yeah, because OpenGL 4.6, there's a lot of things that are desktop only, and you can get it to work on translation to little GPU. Yeah.
Indeed. Yeah, lots of legacy applications, decades of development in graphics and gaming have been using OpenGL, and it's pretty cool to get all this wide ecosystem accelerated to your GPU through the Zinc layer, and of course through the effort that our team put to integrate that with our optimized Vulkan driver.
That's pretty awesome. So
I guess just to bring it back to kind of, the benefits that we're going to see on something like BeagleFlay, right? I think we kind of talked about, at a low level what the technology is, but maybe Robert, you want to speak to, what this is actually going to enable to an end user who's now going to, soon be booting a BeagleFlay with the default image.
Well, that's the thing for the BeagleBoard community as wide. It's going to open up some crazy wide open doors. In the past, we've always had, this one driver, one kernel version, maybe one modules, and one user space. And it's basically, here you go, community, here it is. Use it, don't change it. But with this, Buildroot can have out-of-box acceleration, Debian can have out-of-box acceleration, Fedora can have out-of-box acceleration. If people want to run emulators or they want to do number crunching using the Vulkan compute stuff, they go from it's one image that someone wrote 2 years ago that just works versus
And so no longer are people stuck on old stuff.
Yep. And the Mesa community is pretty large. The amount of translation layers, the amount of optimizations going on, everyone shares the back end of Mesa. So while Imagination did their Vulkan driver front end, when Vulkan 2.0 or OpenGL 5 comes out or OpenCL something with this interface ecosystem, the Imagination GPU can also support that too, until a point when it just doesn't have enough horsepower. But this is something that, once the board gets in the field, you can keep updating it and have Mesa support. Or even the big
normal
one.
Desktop acceleration, so your desktop's going to be faster, web browsing, video playback, right? Things like that.
The simple thing is you just load up Firefox and watch a video. But at the same time, you're not stuck on a 2-year-old kernel that has updates for security reasons. It's just updated and still works. So yeah, for the Beagle community, this is huge. And something that when I started 12, 13 years ago, we just kind of dreamed about. So
we've largely been stuck on like specific builds that we can support, right? So stuff that comes out of the Yocto image, right? Or specific versions of the Debian images where we've kind of gotten everything integrated, but it was only at certain like snapshots, right? This is going to make it where every version keeps working, right? All the new features, into whatever distro, whatever system it can be integrated.
And this allows other people to create their images and create their translation layers. Like, I want to do XYZ, I just need the GPU to work, and then they can release it instead of, well, you got to use this.
Yeah, so Plut, is this doing away with binary blobs completely, or are there still bits in the kernel that are still binary?
There's still the firmware, so.
Yeah, that's correct. The firmware, we consider this being part of the hardware pretty much, so it's doing all the low-level housekeeping on the GPU that wouldn't be that practical for the open source community to intervene and modify.
And the firmware size isn't that bad either. It's pretty small firmware.
Yeah.
And I think for most of the silicon vendors, the same firmware should work. It's just like the power management hooks will have to be in the kernel driver to enable it, I think. But yeah, otherwise it should work on. So while we're talking about TI specifically here, but if someone else was using this BX15 GPU, it could work on another silicon with the same firmware, I believe, right?
Well, the firmware is slightly different in each GPU, right? And that's why we would need to explicitly enable support for additional GPUs. So we are starting out by having one ROG GPU supported, and the thing is that we can easily extend that to the other members of this architecture family, because the driver is very, very similar. There are only small differences in between them, and there is the need for a slightly different binary, though, which is on per GPU basis.
Yeah, because I think on the AM62, it's just the BXE. But for example, like the MediaTek one also works, because that was one of the original BXS Chromebooks that we worked on. But
yeah, we use that as a development platform as well. So yeah, we enabled that.
And I do see one question here from a user. They're asking if you have any plans for previous generation devices as well. So they're asking about BeagleBoard Black, which would be, I believe, SGX 530.
Yeah, I think that's the $1 million question. Is like, will iMation help or hinder the SGX 530 GPU?
Yes. So I'm afraid we don't have any plans at the moment to support SGX family. We have started with ROG because we think that this is how we can make the biggest impact to our customers and the open source community with new devices that are becoming available now. And we plan to be looking into the future as well and enable our newer and higher end GPU generations as well with an open source driver. That's the plan right now, to be more forward looking rather than look into retrofitting the existing open source driver to all their devices, which effectively, wouldn't be as easy as well, because SGX is a completely different architecture. So
yeah, the ROG was
not a trivial task by any means.
And honestly, when we look back, the SGX 530, I mean, we're talking 2005 era. It's finding someone that actually worked on it and understands the core, and then have them try to support it in Mesa. Yeah, that's not a task. You just,
Indeed.
I'd feel sorry for anyone in Imagination that was put that task. It's more of a, if the data books still exist on how to do it. Yeah.
Digging into the history. Yeah.
You mentioned RISC-V. Is there a way to execute RISC-V opcodes, right? Is there a binary RISC-V layer or element, right, to this, right? So I'm trying to figure out what's the tie-in with RISC-V. Maybe it's used underneath the covers, but how would that be exposed to users?
So RISC-V can be a target application processor of the SoC that uses our driver. And when it comes to the open source driver specifically, we haven't been testing that with a RISC-V based SoC, but we see no challenges. Of course, there will be some, technical issues to sort out, but no big architecture challenges should be there. And we expect that very soon we can smoothly run our open source driver on a RISC-V based SoC, similarly as to what we are now achieving with our proprietary DDK, which can smoothly run on RISC-V based SoC.
Looks like there's two parts to that, because iMation was very interested in the RISC-V community. So it's really easy to put the iMation on, like, for example, this board has iMation IP in there. But at the same time, iMation was also using RISC-V inside their IP. So I don't know if the BX, if you could talk about what architecture is inside the BX, but I know iMation's been going towards more RISC-V internal cores than third-party cores. So
Yeah, true. So we are using RISC-V within the GPU as the accelerator for our firmware, and different GPU generations have, and product lines have different firmware CPU inside them.
and that's pretty close to because on your iMation University program, you actually have a course teaching how to use a RISC-V, and I think that's the Swerve core. And isn't that, I would say, it's close or similar to the cores you guys actually use inside your part. So while you're teaching RISC developers how to use RISC-V on an FPGA, it's kind of like iMation has intuitive knowledge of that core because they're actually using it.
Indeed, yeah. So we are using that, and it's the starting point for our own, generation of RISC-V CPUs.
So you also mentioned something along the lines of neural net acceleration, right? Using the GPU cores. I think that you have some separate IP blocks specifically targeting neural network processing, but is something like what's on the AM625 that's and the Beagle Play, is that something that we can get some lift for neural net inference?
Yeah, we have neural network accelerator, and of course, we can accelerate this kind of workload on the GPU as well. And we have the software tools and frameworks that facilitate both paths through a dedicated accelerator, our NNA, or our GPU. And these are both valid paths of acceleration. Of course, GPU offers more programmability, and it's better suited to run new kind of neural network applications that haven't necessarily been the target of a fixed function accelerator.
Something that we can look at working together on for some demos to show it off in the near future.
Indeed, yeah. We do have demos, and I think that we are presenting them in all the different events that we attend.
So that's still using like the Vulkan layer, so we could use the open source, or is that just using the DDK, right? Is that something that we can do with the open source Vulkan driver in a performant way?
Depends on how you want to accelerate your workloads on the GPU. The most typical path is through OpenCL, so that's not something that is currently supported through the Vulkan open source driver. Now, whether or not you could use Vulkan compute capabilities to write some ML content, I guess that's a possibility.
And iMation's university program on the BeagleBone Black AI64, they actually use, and they show how to use it on the OpenCL cores. So doing neural networks, but it uses Imagination's OpenCL driver right now.
So is there a suitable translation layer though? Because if we're not really pushing OpenCL for the open source driver, what would be the open source translation layer, right? I mean,
Yeah, there is that. There are translation layers that take from OpenCL to Vulkan.
But is that going to be reasonably performant, or is there better translation layers that would be suitable for open source neural networks on these GPUs?
So there are two layers. There's the Clover OpenCL driver, and then the new Intel Rust base CL driver. And so these are just translation layers to do later versions of OpenCL. But the problem is all iMation's highly optimized for their OpenCL driver and then all the tools that get tied to it. So it's just a matter of years of optimization versus something that's still relatively new. So out of the
Yeah.
box, yeah, not a chance. But
But I
think
mean, what does the community really look at in terms of? I mean, is it compelling to spend some time on the Rogue GPUs rather than an NPU or some other platform? I know if you look at the BeagleBoard AI 64, you look at the C7 plus MMA, right? There's a lot of open tooling there for that can really be optimized by the community for neural acceleration, right, for inference engine acceleration. But I know that people are looking for more generic programming layers. In the past, TI's gone away from even the OpenCL based support, more just native programming environment, right? And APIs for the OpenVX programming layer, right, for accessing the accelerated kernels, right? And I'm just maybe it really is not something that's like a good CUDA competitor, right? But just trying to understand what the extent of the opportunity is for people to use the Rogue series on Beagle Play, especially to do some improved inference engine support, right? I should have made that a better question.
I'm not sure I can comment, but yeah, give it a try, maybe to let me know if you have something more specific in mind.
And one of the problems of the AI64 too is it's a prior Rogue GPU. So we have the BX on the AM62. The TDA4 is the 8XE part. So it's Rogue family, but it's different.
Yeah.
And if you're doing neural net stuff, right, I mean, you'd really just target the C7 plus MMA plus the C6 DSP cores, right? So those have a lot of there's tool chains that you can use to program those natively, right. So there's lots of example code from TI that implements the TensorFlow Lite acceleration, so that that makes a good target. But of course, that's a more expensive solution that not everybody needs 8 TOPS worth of inference engine support, right? So some lighter compute might be interesting for people if they can make the programming layers work right.
And that's part of the fun too, is while on the GPU side, we can just use Mesa for everything. On the C7, the C6, we have a different compiler, a different programming stack, different programming environment. If we get all 3 of those just to use Vulkan Mesa, it would solve a ton of problems. So maybe that's what we need is a TI to push C7, C6 support into Mesa Vulkan. And then
maybe.
Yeah.
But at least those the build environment, I think for us is still really tough for the OpenVX stack, but it is at least open source, right? It's just not necessarily in a clean build environment.
Yeah. At least we've moved on. Oh, here's the firmware blobs. You just stick in the C7, C6. Like, here's how you can build it. Don't try. Just load the OpenVX firmware. If we could have like that for Vulkan, that would make some interesting.
But if we were able to take all the OpenStack, forget neural network stuff, right? If we're able to take some amount, because we've got 2 other boards with Rogue GPUs, right? The BeagleBoard AI 64, Beagle 5 ahead. Both have the Rogue class, not just because the older boards are SGX. I think the ahead actually has a little bit more because it has the Imagination NPU core as well. I believe it's the Imagination NPU neural processing core there. But if there's an opportunity to use for AI 64 and ahead, some of these open firmwares, it sounds like there's a possibility the firmware loads for working with Vulkan might come.
I think that's part of the fun too. Is GPU is pretty standard. You stick this in the kernel, this kernel directory. Plout, how is the MMA's kernel driver been going as far as where to stick it in the kernel driver, which user space to use? Because there's none of that right now. The situation is pretty much whatever iMation wants to do. You can just write it themselves because there is no open source Mesa for NNA and NPUs.
Correct, and it's a different kind of processor, right? So, however, we are looking into what we can do in the open source space to accelerate, machine learning workloads. We have been using open source as the baseline for all these software tools that we are using. The TVM framework has been used, as the starting point. So, yeah. It is open source that is in the heart of it, and we will be exploring ways to contribute back to the open source community as well.
So that might be a good question too for any developer that is using iMation's MPU or NNA. What software stack should you use to start, working on your application? I mean, with GPU, we know, I'll just use Mesa or Vulkan or OpenGL, just write OpenGL program. What direction are you having your developers go for using the NNA? Like, what tools do you use?
Well, we
Or what language do you even write in? Let's put it that way.
All the standard frameworks, TensorFlow, PyTorch, you name it, everything that VM compile and support throughout as well.
And sorry guys, I'm losing audio, so I might
Yeah,
have to step out.
I think it's just Plow. Oh,
Can you hear me?
yes.
Okay. Not sure if you've heard my response before, but I was saying that we are supporting multiple different frameworks, all the ones that are supported through the TVM compiler. So yeah, TensorFlow, PyTorch, you name it.
I wanted to do a plug at some point here. I don't know how close we are, but I do know of organization looking for people that want to try to improve the state of open source graphics on Beagle Play. If there are individual developers that are looking to contribute, there's some internship opportunities for that. So please do come onto our forums or reach out on the chat to me, and I can put you in contact with the folks looking for that. Right, there's a lot of interest from users of the platform, right, to have developers engaged to try to improve the openness of the stack. So if you're an individual developer, please do reach out.
Bring Jason on Discord.
Mm-hmm. Jake Ragnar. I don't know how close we are to kind of wrapping up, but based on time, we probably should. Is there any other kind of topics, questions we should have asked, things to know about Imagination, the open source efforts?
I think it was a really good discussion that we have, and thank you for the opportunity that you gave me to talk about our open source plans. I think we're getting very close to completing the upstreaming of our first Vulkan open source driver. We're really excited about that. So one step at a time, once we achieve that goal, you will see a lot more contributions from us to the open source space. And we would be also very excited to see what the open source community can do using our open source drivers as a starting point.
Awesome.
Graphics is primarily my focus, personally. I know we are doing a lot of things on the compute and ML side, of things as well. So
thank you very much for coming on, especially with such short notice. So appreciate you making the time.
Yeah, thank you so much, and hopefully we'll have you over again in the future. Once we have everything up and running, and we can discuss about how great everything is.
Cool.
Yeah, I'm looking forward to the day we'd have demos just working out of the box everywhere.
Well, thanks
Thank you,
everyone
guys.
for watching, and we will see you in 2 weeks.